Good afternoon, everyone, and welcome to the day 6, the final day of Atal FDP on Deep Learning, Intelligent Video Analytics, and Computer Vision, organized by PA College of Engineering. Okay, I would like to extend a warm welcome to all of you to the final day of the FDP. So today we have, as per schedule, 3 sessions planned out. So session 11 at 2 p.m. right now. After that, followed by session on introduction on ML ops, and then we have a session on how to comprehend computer visions and research papers. So the current session is on intelligent analytics for tracking and counting, so which is using advanced technologies like AI, machine learning, and computer vision to monitor, analyze, and quantify objects or activities in real time. So these systems can track people, vehicles, or products across environments, providing precise counts and patterns. So some of the application areas, examples like food tracking analysis in stores, vehicle counting at intersections, and inventory tracking in warehouses. So with this, so we'd like to welcome our resource person for the day. So resource person, sir, are you ready, sir?
Yes, I'm ready.
Okay. So welcome to the session, sir.
Thank you. Can you hear me clearly?
Yeah, we can hear you loud and clear, sir.
All right. So let's start by.
So I will hand over the session to you. You can proceed.
Thank you.
Sir.
Thank you very much.
Thank you.
So, Assalamu alaikum wa rahmatullahi wa barakatuh, and good afternoon, everyone. My name is Dr. Ahmed Al-Aqib, and I'm delighted to be here representing Dr. Ahmed Imas and Dr. Muhammad Afif bin Husman, and also representing IIUM for today's workshop. This session is titled Intelligent Analytics for Tracking and Counting Many Projects. It's generously supported by Atal. We are grateful for their support in making this educational possible. During our time together, I aim to provide you with insights and techniques that will not only enhance your understanding, but also equip you with practical skills applicable to real life scenarios. It's my hope that you will find this session both informative and transformative, enabling you to leverage intelligent analytics in your project effectively. So thanks again to Altal for the sponsorship, and let's begin our journey into the world of intelligent analytics. So starting by introducing the object tracking and object counting in a simple way, before we dive into the specific deep learning model that will enhance this objective, which is YOLO V8. So object tracking and counting, these are two fundamental techniques in computer vision that play a crucial role in numerous applications, from security surveillance systems to traffic management and beyond. So object tracking involves identifying an object of interest in a video sequence and following its movement across frames. This capability is essential for scenarios where you need to monitor individuals in crowded scenes or vehicles on busy roads. Object counting, on the other hand, involves quantifying the number of objects or individuals in a scene. This is particularly useful in retail to monitor foot traffic, for example, in event management or crowding control, and in urban planning to analyze vehicle flow. Understanding these concepts will help us appreciate the advancement brought by YOLO V8, which is significantly enhanced both accuracy and efficiency of these stats, of course. Now let's explore more about YOLO V8 abilities, and their principle of that they delivered the state-of-art performance in the real-time object detection. So starting by introducing what is YOLO V8. So YOLO V8 is the one of the latest advancement in the YOLO series uh, for object detection models. It comes from Alterytics. So this Alterytics provided YOLO V8, which stands for providing state-of-the-art performance setting and benchmark in the field. YOLO, on the other hand, stands for you only look once. So building on legacy of its predecessors, YOLO V8 not only enhanced processing speed, efficiency, but also offers an uh, unified framework. This framework is versatile, supporting a range of applications from object detection and instance segmentation to image classification. With these capabilities, YOLO V8 is transforming how we approach real-time image and video analysis, making it an invaluable tool for various advanced applications in technology and research. So let's dive more about on the topic of the models available in YOLO V8. So we will explore the various models available with this model, each tailored to a specific need, ranging from rapid processing to high accuracy detection. So firstly, firstly we have the YOLO V8 Nano, the fastest and smallest model designed for environment where speed is crucial and resources are limited. Next is YOLO V8 Small, which offer balance between speed and accuracy. It's suitable for modern applications. And also we have the YOLO V8 Medium. This one we're going to have like uh, we will code on this YOLO V8 Medium, inshallah. So it provides enhanced accuracy, which is ideal for detailed analysis without significant compromises on speed. The YOLO V8 Large increases the accuracy further, but it's at slower processing rate
Excuse me,
compared.
sir.
Yes,
Sorry to interrupt. We are getting noise, background noise from your mic. Is there any possible I can switch to directly to the
all
computer?
right. Just a moment. Let me check. Is it now better?
Yeah, better, sir.
All right. So we've reached
The
the.
noise is again back, sir.
All right. Let me change the mic. What about now?
Now it is better, sir.
All right. So we have reached the last model, which is YOLO V8 extra large model, or YOLO V8X, which offers the highest level of accuracy, making it the best choice for application where precision is paramount. The so it's the slowest among the models. Additionally, YOLO V8 comes bundled with the pre-trained model for different tasks. For example, we have the object detection. For object detection, we have checkpoints trained on Cuckoo detection dataset with the image resolution of 630 and 640 pixels. And for instance segmentation, the models are trained on the Cuckoo segmentation dataset also at 640 pixel resolution. And for image classification, the models are trained on the ImageNet popular dataset with a resolution of 224 pixels. Each of these pre-trained models is ready to be deployed, making it easier for developer and researchers to integrate state-of-art detection capabilities into their project quickly. We have here a comparison between the detection of uh, between the output of the yellow VX for object detection and nested segmentation. You can notice that the object detection on the left and the nested segmentation on the right. For the nested segmentation, it has the objects colored red. So now let's have like a quick comparison for the performance of the Yellow V8 and the previous one, one of the previous models, which is the Yellow V5. So this chart highlighted the key enhancement across different models. The Nano model shows the largest gain with over plus 30% in detection and 32% in segmentation. The small model improves by 20% increase in detection and 18% in segmentation. The medium and large model see moderate improvement, particularly in detection and segmentation also. But the XL large model boosts the detection by 6%, although it slightly reduces classification performance. This metrics demonstrated Yellow V8's enhancement capability across various tasks, allowing for tailored uh, model detection based on specific performance needs. So let's dive into more about the object tracking and why it's important to our uh, talk today. So for the object tracking with the YOLO V8, firstly, it enhanced the traditional object detection. This advanced method goes beyond identifying objects in the single frame by assigning and maintaining a unique ID. This is the trick of it for each object, enabling us to track their movement across sequence frames. You might also wonder if simply detecting an object in every frame is sufficient. However, tracking is crucial for overcoming challenges such as a collision, where objects may obscure or blend into the background, making a continuous detection difficult. Tracking also ensures continuity, maintaining constant identification and monitoring of objects throughout the video sequence, which enhance both accuracy and reliability of the analysis. Uh, so there is a question why we combine detection with tracking. Simply, detection provides a snapshot of what in each frame, but tracking connects these snapshots across the entire video. This integration is essential for applications like surveillance or sports analytics, where understanding the trajectory and behavior of the object over time valuable and will, will yield invaluable insights. So, in instance, object tracking with YOLO V8 not only enhance detection capabilities but also provide a comprehensive tool for analyzing dynamic scenes, crucial for road applications. Uh, let's move to the comparison between the single and multi-object tracking. We have here like very simple GIF that illustrate what's the difference. You can see clearly the difference between them. So, in the realm of object tracking, starting with a single object tracker, which called SOT. The SOT system begin by making an object in the first frame with a rectangle to specify our tracking target. This object is then followed through sequence frame using a tracking algorithm, which are tools provided from OpenCV.
provide building trackers such as uh, KCF, DLD, and GoTerm, which are particularly used in real life application where precision tracking of a single object is needed. On the other hand, moving to the multi-object trackers or MOT, when dealing with scenarios that involve multiple moving objects using a fast object detector in combination with an MOT system is crucial. Systems like deep uh, Gate MOT, byte track, and bot sort analyze advanced algorithm efficiently track numerous objects across the video sequence. These systems are uh, indissoluble, indissoluble in complex environment where multiple objects interact, such as in busy urban or sport or in public gatherings. So, in summary, whether tracking a single item or multi objects, the choice of the choice of track depends on the specific requirements of the application. With SOT being ideal for focus tracking, and MOT designed for border dynamic environments. So here we have the object counting. For object counting with YOLO V8, it's a powerful extension of our object detection capability. It starts with the identification of object within a video frame, and these objects are then meticulously tracked across frames using advanced algorithms such as uh, bot sort or byte track. So let's break it into counting methods. We have, for example, the whole frame counting, which is involved counting every object presence within the entire frame. We have also the uh, in and out counting, which is differentiate between objects entering or exiting specific zones, providing valuable direction data. For example, we can use it for traffic. And on the other hand, we have also uh, zone-based counting, which is focusing on counting objects within designed area, which is specifically useful for environment like retail spaces and such on. And lastly, we have the line counting, which tells objects as they across a specific line. It's ideal for monitoring traffic flows of entry points and objects, and to ensure the accuracy and prevent issues like double counting, particularly in complex scenarios with a collision or dynamic environment and dynamic movements. We maintain objects in a counting list. We will see later in the code. The count is carefully incremented only when certain conditions are met. Uh, this method yields very important data that enhance that enhance an insight across the traffic management and retail analytics, demonstrating the importance of the YOLO V8 in real-world application. So I think here we can move on to the code. So I've provided two codes to explore. I'll be sharing the link in the chat right now. So this file in this drive, you will find these files. First, these two files are the videos we are going to analyze. These are this containing the notebook, which containing the codes, and here is the output we will get from the codes. So let's start by viewing for example, let's start by the video of the people. So as you can see, there's a scene where people are walking across the street. So after we run the code, we should get something like this, like this. So this method is for counting for the whole frame. As you can see here, the number is increasing. It's not very clear. So it's counting every person in the frame, in the entire frame. This is the first method we are going to explore. The second method will be the output video on the top. We will when we will have like cars going down the street, and then we will count how many cars are crossing this line. As you can see here, the number is increasing until it reaches 70 cars, 70 vehicles. So I hope you can open this code. First thing, of course, you have to link your drive by this code here. You need to set up the environment as well. So from Google Display App, you will import drive, and then you will mount your drive right here. Let's do it together. First, you have to get access to your drive. So after we started this code, we have mounted the Google Drive to save and access files directly from our collab environment, and then we will uh, ready the path for the video. As you can see here, it's in the content drive, my drive. This is the name of the project, and this is the name of the video. So we run this code. Afterwards, we install the important library. We installed Outvertex and also OpenCV for Python. We also install this library. So I have it here installed very fast. Let's go to this code. This code here is for the tracker. We're using a tracker called sort. So we first prepare the tracker by this code, which will install the sort.py. This is the file uh, responsible of the tracking. And then we modify the file to remove the matplot. It will cause some problems with the code later. So the whole code here is to remove the matplot. So we run this code. After it's run successfully, we here import uh, the libraries. So we have installed the libraries already. So now here we can import it. Hopefully not going to get wrong. We have imported the OpenCV, NumPy, time. We have imported Google Colab patches to import the DB2M show to show to display our images, and also Alterytics for importing YOLO. We also imported the track, so we didn't see any error here, so it's imported successfully. Here we define our path to the video output. So this will later be included in the main code. We will save the video, the outputted video, and a folder called output. We'll find it in the drive. We go to the drive, we'll find output. Here the video will be stored. So let's start to explain the main code here. Let me run it first, or maybe I explain first. So we first we load the model by writing model is equal to YOLO model path. This model path is giving or let me run it. That's an error. So instead of writing this, just name this one. So by this it will directly import the model from Alterytics. So YOLO model will load the model specified here, and then uh, we'll initialize the tracker, which is sort. The tracker parameters, it will define the behavior in terms of object aging, aging hits before tracking, and intersection over union. Mm, we have here the video processing part. So this code right here will capture the video. This one right here will get the properties. We'll get the width and height of the video and for each frame, and the FBS. We'll need it for analyzing. You can see here we can try the FBS by getting this function. It will get DB2 capture of FBS. And here the same for the width, and here's also the same for the height. Then we will initialize the video writer. This is for the output. So Here we will set the unique ID. As we said, the unique ID is crucial to identifying the objects and counting. Otherwise, we will count for every object in each frame, which will result in high counts and not accurate. So we will then write this code, which is while true, return frame with read. If not read, it will break, will end the video. It didn't read any, return any video. Here we have the code for detecting the object in each frame, which is inside the loop. Here it will use the model we have initialized. For after it detects after it detects the object, it will filter the detection. We have used here person. So the filter detection for person will get for R results. Box is equal to R boxes. For P box in boxes, you will define it will get the box for each detection. And it will update the tracker with the current detection to retain the tracker object with their coordinates and a unique ID. Uh,
Dear sir,
yes,
can you zoom the code little?
all right. So, probably- so let's continue. For this one right here, after detect the boxes, it will give it like a specific ID, unique IDs, and if they classified its person, then it will draw the rectangle frame on it with these parameters, the x and y extracted, and will give it this color, which is blue, as you can see. This is the thickness, and it also book the text. It will book the name of it, which is person, with the font. Also have some offset for the y2 and y1. Here for tracking and counting, the result tracker will update the track with the current detection. It returns the track object with their coordinates and unique ID, and also counting unique IDs, maintain set of scene IDs. If a new ID is detected, it will add it to the set effectively, counting unique individuals over time. Alright, that's okay. It's going to be the same for oh, okay. Is it clear now? I think we fix it. So after it updates the tracker with the sections, it processes for each track person and this color here with the ID. The ID is not seen, then it will eliminate it. Then it will display the total count per unique person. So for here, for example, total person equal to this. in ID. You will have it with this number of unique persons on the top. And then it will write it to the output video frame, the new frames of the new video. Then it will show it. We have some time delay to overwhelm the collab. Always great as we have seen like previously. Uh, then it was released. So let's see right here, some photos for example. This is a downside for collab where actually cannot process like video immediately except we do like very complex code. So go down, yeah, this is the last part. So for example, here are 22 persons, which are where the unique person, they count, they find their 20 detections, the unique ID, and it also will give you like uh should give you I think because it crashed, but should give you the videos has been outputted to the drive. I hope you can run this code. Let's do the other one for the cards. Okay, it start. I don't know, it just started raining, then the collab didn't work. Like I have the VS code. I'll try to explain it right here for the VS code instead of doing the collab because it's not working. So for example, when you use VS Code, you have to first set up the environment. Not like collab can immediately work on it just by importing and downloading easily. Just like simple codes. So we have to like this stuff. You can do it also for VS Code, but it'll be a little bit complicated. So we import because I already installed the libraries. We just import the DB2, which is OpenTV, Albertic, or YOLO, sort, import it as this, simple. And then we import the video for the card. We read it. Afterwards, we define the model, okay, YOLO V8M, PT. And afterwards, we define the counting line. So this line will be defining the video frame, presenting the start and end coordinates. For example, here X and X and Y on the other side. And then you initialize the tracker sort. You put their specific parameters, max 8, just 20 to determine how long tracker will keep in the and we keep ID without updates, 50 for 20 milliseconds. And also mini hit 3, it will define how many detections are required before a tracker is confirmed. And also the IOU threshold is also set to 0.3 to manage the overlap in detection for constant tracking. So here you open the video frame, you open the video file, and set up the warnings if something is wrong. So in result model, each frame processed using the yellow model to detect objects. Result result are filtered to focus on person detection. Mm, For each person detected, there is a bounding box. Mm, So for this, the whole part here will extract the bounding box and proceed for tracking. After it gets the bounding box, we'll deliver it to the tracker, the result tracker. We have set it to sort previously. So it will update with the current frame detection and return the data on track objects, including their ID and updated bounding boxes. So this is for the cars. It's unique a little bit. So after you get the ID and the bounding box, we'll draw a circle in the middle. As you can see, we can get the circle by this equation, and also it will draw a rectangle around the car, and it also got the text above the with the ID and the detected object. Here we can define the ROI boundaries. Let's transfer this working fine. As you can see right here, we have the cars. We have the center circle in it. So whenever the center crosses the line, okay, this one to make it slower. So whenever the circle crosses the line, it will count for one, as you can see here. So the idea is only checking the bounding box of the detected car, tracking it, not to result in a collision or something, and then identify the center of the bounding box, detected, drawing the line, and then counting if every circle is crossed this line, it will count for one until we increment. So this is how we can do the counting. Someone is asking to share the notebook resources. You can find everything here in this drive. You can find the notebooks here in this folder. I'll share you the link. You have a look. See, the time is uh, approaching the end. So this concludes. What are the things that we can take away from this session real quick? So let's summarize the capability and importance of Euro V8 in object tracking and counting. Firstly, the Euro V8 for object tracking. This model with interfacing with sort represent a forefront for object detection technology. It's quick and accurate for detecting objects and also translating this detection for tracking, making it like uh, good for real-time analysis. And also the importance of object tracking. While detecting is very important, also the tracking is on the same level. So in each video frame, you should track and give the object uh, an ID, a unique one, to overcome the collisions and multi-detecting single object for and counting like for many times for a single object. We also have the types of object tracking. So ULV8 supports the single and multiple object tracking, which interact seamlessly with the need of the project. And also we studied about the object tracking and counting, how many technologies we can use. For example, for this application is right here. So we can have like specific region of interest that we can count in. We have this line is the same as the car one, which is identify the center line when it crosses the center of the bounding box. When it crosses the line, then it will count for one, as you can see. And also for in and out, and this is for the whole frame. I hope you will get benefit of this. You can provide me with any questions you have. If the code is not working, I hope you can access the drive and get the Google Lab work.
Sir, we have a question from the audience.
Yes, please.
What are the performance metrics used for object detection and tracking? Sir,
Yes,
can you take this question?
yes. So uh, you can say that performance metric and object detection tracking will help to quantify the accuracy and efficiency of the model. Uh, for example, precision and recall. For precision measures, precision will measure the accuracy positive predictions in the object detection. It refers to the percentage of the correct positive predictions among all the positive prediction made. While the recall, it assesses how well the model detects an order level instance. We have also the IOU, uh, which is an intersection over union. This is very crucial for the metric and object detection. It measures the overlap between the predicted bounding box and the ground truth box. As we get closer to the ground truth box, it will score near to one, which and it get the perfect lap, perfect overlap. Of course. What else we have? Mm, we have the mean average perception, which calculates the across all classes over the IOU threshold, which provides like single figure that captures the overall effectiveness of the model across multiple classes. What else we can include? Maybe a very important metric, which is the frames per second. I think that's all. I hope I answered it.
Sir, so we have one more question.
Yes.
The question is, how is the recorded video and the live video? Will there be any difference in the performance for analyzing this?
It's actually all depending on the FPS. So if your video that you're using the same FPS as the camera, to be the same FPS. And also, it depends on the how many objects are in the scene.
So
So,
next question is YOLO able to detect very small objects, and what is the minimum and maximum distance from the camera?
mm, let me think about it because I need to recall. I think for this one, depending on my research, it depends on the yellow model version. So if you get like yellow V4, it will have like less performance than yellow V8, of course, for detecting small objects because yellow V8 has the ability to detect small objects. So if you want to use yellow for detecting small objects, I advise you to use like new models, yellow V8 and above. For the minimum and maximum distance, I'm not sure actually. You think you have to try it. That's it.
So how do we generate the reports for the analysis of these objects, sir? Will it be in the form of a statistical, or is there any tool to generate reports after the analysis?
Mm. So if you want to generate report for yellow, uh, after you collect the data, maybe you can use like graphs So, for example, you can evaluate the performance, uh, the performance metrics like precision, recall, MAP, the FPS, all of them in about the tools. Brother Ahmed Rimas, do you have any idea for the tools?
Any more questions from the audience? If you are having questions, you can unmute and ask.
For the one who asked about the processing tools, I think you can use Python. You can use libraries like NumPy, Pandas, or manipulation, Matplotlib. These are beneficial for data analysis.
Dear participants, kindly fill the feedback at the earliest. Dear participant, a short break of 10 minutes is announced. The meeting will be live, and if you want, you can join back after the feedback. So 10 minutes break is announced. Kindly join for the next session. Thank you.